And then, once you multiply the first one, will you multiply the second one? Is that about what you got? When you FOIL it out? Okay, what happens with the, any like terms happening here? Those are imaginary numbers. 3i, take away 3i, they're gone. What's I squared again? So doesn't this say, that's negative 1i squared, so that's negative 1 times negative 1, right? So this says 9 plus 1, right? Did you get 10? Okay. Any questions? No? Okay. Next one. What'd you do when you FOILed it out? You worked it all out. You added like terms, and you got what answer, Howard?
35.
35.
No, 25. Oh, sorry.
25? Okay. That's what? 16. What's this? Minus 12i. What's this? Plus 12i. What's this? Minus 9i squared. But that is negative 9 times negative 1, right? So this really says what? Plus 9. Okay. 16 plus 9. 25. 12i, take away 12i. 0.
Yeah,
Sorry.
I
That's okay.
thought too quick.
That's okay. Happens. Yes, no? You okay?
Yeah.
Okay. So you multiply this, you multiply that, and then I ask you to do it again. And then I say what? What name do we give? What name do we give these binomials? Okay, 3 plus I times 3 minus I. 4 plus 3i times 4 minus 3i. There's a name that we talked about back in Algebra 2. Say again. Conjugates. Good. They're called conjugates. Okay? Now what's a conjugate? Well, here's basically all it is. 3 plus I and 3 minus I. Well, notice the 3 and the 3 do not change. Look at the second term. It's positive I, now it's what? Minus I, it's the opposite. Here it's plus 3i, now it's minus 3i. This is plus 3i, this is minus 3i. You guys, that's all conjugates are. They're just, the second term gets switched to its opposite. And here's the real word you're looking for. They're called what? Complex conjugates. Now, what is a complex number? Okay, let's come over here. You might want to write this down. I think I did this last Tuesday, I think. A complex number is simply this, A plus BI. A plus BI. Okay, where this is known as the what part? The real part, that's an A, sorry. The real part. This is known as the what part? Imaginary part. So here's an example. A could be 5 plus the imaginary part could be 6i. So that's called a complex number. Okay? Complex, now when I say complex conjugate, then you have to tell me what's the conjugate to 1 plus 3i? You'll say what? 1 minus 3i. Yeah? Okay, so what happens? Every time we do this, we multiply and we just get a number. We just get a number. Every time we do it, we get just a number. So will you do this last one right now? I don't know if you already did it or not. Have you done it? Okay. Some people have, some people haven't. Go ahead and finish it up. 1, what's this right here? That's negative 9 times negative 1. So really it's 1 plus 9. The answer is what? 10. Oh, look, another number came out. 10 came out. 25 came out. What came out? What's that number? 10. 10, 25, 10. Basically, a number keeps coming out. Okay, so when do we use complex conjugates when it comes to imaginary numbers? Yeah, it is division. Okay, what I'm trying to tell you is this. Do you guys remember this? You cannot divide by what? 0. It's impossible. What's the answer to this? Undefined. There is no answer, right? Undefined. Okay, what else you cannot divide by? You can't divide by
Square root of negative.
radicals that you don't know the square root of, like 3. 10 divided by the square root of 3. How come? They're irrational, which means what? No, they're real. They're real numbers. They're just irrational. They are decimals that go on forever, okay? And they don't repeat, so you really never know what you're dividing by. So if you don't know what you're dividing by, how are you going to divide? So you know what we do to these? We rationalize these. We multiply them by what? Themselves. And then we go like this. And then we say 10 what? 10 square root of 3 divided by 3. Now we know we're dividing by 3. If we can divide by 3, 3 is just a number. It's 3. It's easy. But this is a number, and it goes on forever. So how do I divide by a number that never quits? I can't. So that's what you do. Well, when else can you not divide? 0, radicals, and what else? Imaginary. You can't divide by imaginary numbers. So how are you going to get rid of this imaginary number on the bottom?
Okay.
Tommy? Yeah, take the 2 minus 3i times what? 2 plus 3i. Okay, do that right now. And by the way, what you do on the bottom, you got to do on the top. You can't treat the bottom any differently than the top. There you go. Take a little time, multiply both. See what happens. Yes, no? Is that what you got on top? 3 plus 11i. On the bottom, you know what, guys? I left that blank for a reason. Will you tell me something you noticed about all 3 problems up above? What? You get one number, right. But before you got that one number, what always happened in the problems up above?
The 2 canceled out.
Yeah, the two middle terms did what? Canceled out. You know where those 2 middle terms come from? When it comes to foiling? Inner, inner, outer, outer. You really don't have to do it. Why would you have to do it if they always cancel out? So really, could I get away with this? First. 4. I don't have to do outer, outer, or inner, inner, because they're going to cancel out. Just do last, last. What's this give you? Negative 9 I squared. But negative 9i squared is really positive what? 9. 4 plus 9 is 13. Now, here's the deal. In the back of your book, it always says this. Write your answer as a complex number. Oh, you want me to write it as a complex number? That would mean give me real part plus imaginary part. So the real part to this problem is what? 3 what? 3/13 plus the imaginary part is what? 11/13 times I. This is the way the back of the book will write it the rest of the year. Whenever they talk about complex numbers, they're going to write it like this. The real part plus the imaginary. If you want your answer to look like theirs, yes. And that's how the instructions say. The instructions will say, write your answer as what? A complex number. Well, what's a complex number? It's a real part plus an imaginary part. Okay? Now, one thing I want to tell you about complex numbers. If your number is simply, if your answer is 10, how do you write 10 as a complex number? 10 plus 0i. Now it's written as what? A complex number. Why would I ever write plus 0i? I wouldn't. But if the book says write it as a complex number, that's the answer. Okay? What if your answer is simply just 6i? How do you write 6i as a complex number? Real part plus what? Imaginary part. They call this a pure imaginary number. Just imaginary. No real part. Okay? I don't know. This is in your, I think this was this in your assignment? Last Thursday or Tuesday? Pure imaginary? I think it was. I didn't talk about it, but that's what it is. Okay? All right, I think your slides are done. I have 2 more. These 3 problems, I'd like you to multiply, subtract, and then do whatever this means to you. What does that mean for you to do? So I don't know where you're going to do this. Just take out a sheet of paper or whatever, find some spot. But, do you see radicals up here all over the place? Yeah, I see radical. What's the square root of -3? First of all, you can't take the square root of -3. So get rid of that. What should you write instead? 3i. No, not 3i. Watch this, guys. Square root of -3 is -1 times I. So what is this? Square root of -1.
I squared.
I. Square root of 3. Square root of 3 is what? Nothing. You don't know it. Square root of 3. What's this one going to be? This one. I square root of 6. Yeah. Don't do these problems until you get them to become imaginary numbers. Because you really don't know what the square root of -3 is. But you do know it stands for this in the imaginary world. Now do this times this and tell me what you get. You guys see nothing but what here? Multiply, multiply, multiply. Just do what seems easy. What's I times I?
I squared.
I squared. What's the square root of 3 times square root of 6? Square root of 18, yeah. I squared times square root of 18, but 18, what about the square root of 18? Broken down to what? Yep. What's the square root of 9? 3. What's the square root of I? Oh, sorry. What's I squared?
-1.
So it's really 3 times -1, which would make it what?
-3.
-3 times square root of 2. Yeah? Don't start these problems until you make them imaginary. Ryan, what is this in imaginary?
I square root of 48.
Say again.
I square root of 48.
Okay, but
Yeah.
But.
Broken up into
I think 48 can be broken down into.
Yeah.
4 square root of 3.
Okay. So you're telling me, I think what you're telling me is this. 16 times 3, right?
Yeah.
Okay. So 48 can be broken into 16 and 3, which means this is what? 4, then I, then square root of 3, right? Subtract square root of negative 27. The way I would think of it, guys, is like this. I think of it like this. Right? Square root of 9, 3. Square root of negative 1, I. So 3i. And then what? Square root of 3. What's your memory when it comes to adding or subtracting radicals? What?
Just the outside.
Okay, you're talking just the outside. You're saying they have to have same what? The radicand, yeah. This number inside has to be the same. Square root of 3, square root of 3. You have like radicals. And now, Howard, you're telling me to take the outside number called the coefficient minus the other coefficient, which is what? 1i. Or just I, and the square root of 3. Right? Think of like terms or like radicals. That little 2 out there, what's it mean? Andrew, what do you think? That little thing. Square it?
Yes.
Okay, so what should I write?
Make another parentheses and then point.
So you're telling me make another set.
Oh yeah, yeah.
So you're saying negative 1 plus this times negative 1 plus this. Okay, anytime you see a square, guys, it means to multiply that number times itself twice. If that was a 3, you'd do it 3 times. Don't start until you do what, though? Make them imaginary. Okay, Katie. Square root of negative 3 is what? She says I square root of 3. Is she right? Yes, she's right. Negative 1 plus I square root of 3. Now FOIL it. Like somebody already said this. FOIL it up. Negative 1, negative 1. 1. That would be negative I square root of 3. This would be what? Negative I square root of 3. And this would be kind of a mess. What? I times I? I squared. Square root of 3 times square root of 3 is 3. Hang on. I told you it's a mess. It says 3 times I squared. Negative 3. Well, no, I squared is negative 1. 3 times negative 1 is what? This is really saying minus 3 back here, guys. Okay, what's 1? Take away 3? Okay. We have like radicals. How many square roots of 3's do I have? Negative 1i and another negative 1i, which makes
2.
negative 2i square root of what? 3. I call that the answer. Yeah? Is that a complex looking number? Okay, here's the real part, negative 2. The imaginary part would be negative 2 square root of 3i. I don't like I in the back, so I put I out in front. Okay? Questions? One last slide, here we go. Would you take this function right here and identify what? Any zeros. I would like you to get the zeros of the function. And you need to do it by what? Graphing. How? How do we get the zeros? Find what? The vertex. Well, the vertex will probably not be the 0, but it's a starting point, right? Okay. And by the way, he said vertex because he knows it's a what? You guys know it's a parabola? Why?
Square.
It's quadratic right there. It's right there. It's a quadratic function. It's a parabola. Go find the vertex. This is what you did on your quiz, by the way. You did this quiz on Wednesday last week, right? Hopefully you remember that. To get the vertex, you could complete the square if you wanted, or this would do it, wouldn't it? Negative b over 2a would get you the x value of your vertex. Opposite of b is what? 2. Over 2 times what? 3, which makes 2 over 6, which makes 1/3, comma, something. What'd you get? 2/3, okay. And you probably got the 2/3 because you went right back up here, didn't you? And you wrote this, or maybe you typed it in, I don't know. And then you wrote, which gave you what? 2/3, right? Okay, so if you go graph it, here's 1, here's 1 up, I guess, over 1/3, up 2/3, right? I suppose you're about right here. Okay, what are we looking for? Graph the function and give me any zeros. Which way does this parabola go? How do you know it's up? Positive 3. It's got to go up, up. Up on the right, up on the left. Okay, where are my zeros? No, zeros are what x values will give you 0 for y. There's not, right? Do you guys see anywhere on here where it hits the x-axis? No. So no what? No zeros. But guys, guess what? Look what I'm going to put here. No. There's no real zeros. But there are, zeros are really just solutions, just so you know that. There are solutions to this equation. I know you don't see any zeros, but here's the deal. There is a number, if you put it in here and you put it in here, you're going to get what? You're going to get 0. So you know what I did? I did it again down here. So what number for x and x that I plug in, when will I get 0? Well, by the looks of the graph, never. No what? But guess what there are? There's imaginary zeros. And I told you to go find them using what? There you go. I'll give you a 30-second head start. Go. Go get the imaginary zeros. Guys, if anything, this is good practice using the quadratic formula. What's your B? Your B is -2. What do you put out here, though?
2.
Opposite of B. Okay, 2. And then here you put in B, and then you square it. -4 times A. What's A? 3. And C is 1. And then A is 3. So I'm going to get 6 on the bottom. What's inside? This is 4 Negative times positive is negative. 12, 1, that's 12. So you're getting what? You should have got negative 8. Move across. Here we go. 2 plus or minus. Okay. 2i. 2i squared of 2. Right? Look at what you have. You have a real part of 2 over 6, which is 1/3 plus or minus 2 over 6 again is 1/3, but I could just write I third square root of 2. You know what these are? These are your zeros. If you put these two solutions into x and you do exactly what it says to do, if I put those answers right here, 3 times x squared minus 2 times x plus 1, if I put those imaginary numbers here, I'll get 0. I will get 0. I'm not going to do it, but I will get it. But I want to show you something. Do imaginary zeros show up on the graph as x-intercepts? No. There are 2 solutions to this problem. They are imaginary. They're down there. But when you look at the graph, do you see them? No. You never see imaginary zeros. You won't see it. But they're there. They actually will work if we plug them in. I'm done. You have the remainder of the hour, which is now, what, 20 minutes? Mr. Mashalik is in the back of the classroom. He's sat in here for 2 hours now, and he's heard the same lecture twice. He might circle around, and if you want to ask him a question, go ahead.
I have class at 2, so I have to leave.
Oh.
Too much right now.
Oh, sorry. He probably won't be walking around. Sorry. Okay. So, you got 20 minutes. Give me 5 minutes to hand back your quiz. In the last 15 minutes, I will collect your quizzes and ask you what your question is. Who did not take the quiz last week? Molly. And Molly. Just Molly. So you can move there. See you tomorrow. You've been sitting with the seniors and helping with the assignment.
Wait, we have to add this.